number 28, it says, which expression is equivalent to negative 256x to the 18th? So I need to basically simplify any of these to see which one is going to be equivalent to negative 256x to the 18th. To do that, I need to know a few of my exponent rules. So one of the rules we need to know is that if we take x to the 5th, none of my pens are working today, x to the 5th, and then raise that to another power, we actually multiply these values. So I end up with x to the 10th. Now, if I have something like x to the 5th times x squared, I end up with x to the 7th. So I think those are the two rules that we need to know. When we multiply powers with the same base, we add the exponents, and when we raise powers to other powers, we multiply the exponents. So we're looking here and going to see what we can do to get x to the 18th. I'm mostly going to focus on the x's, and then if we still have choices left, I'll see if we can find the negative 256. So I'm going to start with a. If I look at my x's here, I would have x to the 3rd raised to the 4th power. That would multiply, so I would get x to the 12th. Then I would have x to the 12th times x to the 4th. So when I multiply them like this, 12 to the 4th, I just add those up. So 12 plus 4. Well, 12 plus 4 is only 16, so I would end up with x to the 16th if this was my choice. I need x to the 18th, so A is not going to work. For B, let's see, I have x to the 3rd, and I'm going to multiply that times this, which is going to be x to the, well, power raised to a power. I'm going to multiply these two values, so I end up with x to the 20th. When I multiply x to the 3rd times x to the 20th, I get, I add these up, I get x to the 23rd, which is too many. So B is also out of the question. Here, this part would become x to the 12th. This part would become x to the 6th. So I have x to the 12th, x to the 6th, and if I had x to the 12th times x to the 6th, I add up 12 and 6, I get 18. So C looks like it could be a possibility. But I don't know if these numbers multiply out to negative 256, so I have to look at that still. If I do x to the 8th times x to the 8th, multiplying powers with the same bases, I add the exponents, I'm going to get x to the 16th, which is not what I'm looking for, so that's not going to work. Here, I get x to the 2nd, and here I would get x to the 10th. If I multiply x to the 2nd times x to the 10th, then I add up those exponents, I would get x to the 12th. Again, not what I'm looking for. So the only one that gives me the right x value is 18. You would want to double check here. I'll show you what this problem would look like simplified. So if I have negative 4x to the 4th, all raised to the 3rd power, times 2x to the 3rd, all raised to the 2nd power. That means each part in here gets raised to the 3rd power. So I have negative 4 to the 3rd and x to the 4th raised to the 3rd. Same thing here, 2 squared and x to the 3rd. Whoops, squared. So I end up with a statement. Negative 4 to the 3rd would be negative 4 times negative 4 times negative 4, which would give me negative 64. This would become x to the 12th. This would become 4. And this would become x to the 6th. Now, I can reorder this, so I can say I want to take negative 64 and multiply it times 4, which gives me that negative 256. And I can also say these two times each other, x to the 12th times x to the 6th. When I multiply powers with the same bases, I add the exponents, I end up with x to the 18th. So I end up with that negative 256 from these two numbers, and then x to the 18th from those two. So it looks like C is the correct answer.